micro is a bacterium, and it's a bacterium that we isolated from forest soil. And that forest soil we actually collected not far from here, from near Quabbin Reservoir. Was part of a study that we had been pursuing for many years in the lab, and the study was to understand the microbes that are involved in the carbon cycle, and very specifically the bacteria or the microbes that are involved in the breakdown of plant material in the absence of oxygen. So we were interested in microbes that are able to grow in pond sediments where oxygen is limiting, depleted, and are able to break down plant material, and it's an important part of returning the carbon to, to the atmosphere. They play an important role in the carbon cycle. Well, so we had all of these isolates, bacteria that could break down plant material, and what we did, the way we got them, was we grew them on paper, filter paper, Wattman #1 filter paper in the lab. So we had all of these isolates from soils and sediments from around the world that could grow on paper or cellulose, which is the main component of plant material. And what we did was we compared them. We looked at their appearance, their morphology, we looked at their physiology, what are the sorts of products that they make when they carry out this breakdown. It's a fermentation, so they're able to ferment the cellulose. And when we did that, it turned out that most of our isolates, and we had many of these, dozens and dozens, most of them turned out to be pretty similar. They were similar in their properties, and they were also genetically related. But there was this one microbe, our one isolate, that stood out as being very different, genetically different, and also physiologically different, and even morphologically different in appearance. And that was the Q microbe. What we learned fairly recently is that not only does it make ethanol, it makes a lot of ethanol, and ethanol is the main fermentation product from all of these components of biomass. And so that's what initially suggested that this was a potential biomass organism. And then to get to sunethanol and eventually Q-Teres, once we realized that, it was just a short period of time where it became apparent the only way to actually get this technology that we had developed now for biofuels formation, to get it out of the lab and into the marketplace, and that was to form a company. The more general term for it is consolidated bioprocessing. That is, you consolidate the enzyme step and the fermentation step into one big vat, essentially. And when you do that, there's enormous savings in terms. Benefit is that we can take what's now considered waste material and convert it into a fuel. And this waste plant material is, it's produced by plants. So what they do is they take up carbon dioxide from the air. Then when we convert it into fuel, we burn up that fuel and return the CO2 to the air. But it's the same CO2 that the plants take up. So this is a sustainable process that doesn't have a net CO2 generation. And if you compare that to what we're doing now, which is using fossil fuel, we're digging that fuel out of the ground and we're burning it up and we're pumping that CO2 into the atmosphere.